G'day everyone. In this video we're going to talk about measures of central tendency, but before we do that, have a think about this. Mr. Hall has gone bowling 6 times in his life, and these were his scores: 85, 115, 160, 110, 115, 111. He's going bowling again on this Friday night. What do you think he will score? Okay, how are you going to work out what do you think he'll score? You can take a guess. I don't know, 112. But how do you know if that guess is right? Well, this is where we talk about measures of central tendency. We talk about averages. Now, average, there's 3 types of average, and it's really important you get this, that average isn't just mean, but also median and mode. So we're going to look at what mean, median, and mode are, and how to calculate them, and how useful they are. So mean, also called arithmetic mean, is the sum of the numbers divided by how many numbers there are. The median is the middle number when you arrange them in ascending or descending order. Now if there's an even number, the middle is going to be the mean of the 2 numbers in the middle. And then the mode is the most frequently occurring. Mode, if you speak French or German, you know mode. Mode means fashion, so it's the most fashionable number. Now sometimes there can be no mode, sometimes there'll be 2 modes, or even 3, depending on how much data you had. Okay, and if it's group data, you might talk about a modal range, but we'll see that later on. Okay, here's an example. There are a bunch of students here. These are their ages. What's their average age? Well, average, do you want mean, median, or mode? Don't know. Let's work out all 3. Well, the mean would be you add up all their numbers and divide them by 8, because there are 1, 2, 3, 4, 5, 6, 7, 8 students. So the mean age is 21.75 years old. The median age would be the middle number, so you put them in order and you cancel out until you get to the middle, and the middle is halfway between 20 and 22, which is obviously 21. If it's not so easy to see, you can add them together and divide them by 2. The other way you can do it, and you say, okay, there's 8 numbers there. 8 plus 1 is 9. 9 divided by 2 is 4.5. So it's the 4.5, if that's a word, 4.5 number, which will be the number in between 20 and 22. And the mode is 18, because there's 2 18-year-olds and no other age is reported. So if you want to say what's the average age of this group, which one do you think would be the best? I don't think 18 would be very useful as an average, but you could make an argument for both 21 or 21.75. That's maybe something you can discuss together now, if you've got someone else there with you. Okay, here's another example. I live on kind of a busy suburban street, and the average speed along my street of cars is this many kilometers per hour. I recorded 15 different cars with my radar gun that I own. I don't know how I got these numbers, but anyway, these are the 15 different numbers of cars and the speeds. I want to work out the average speed. Well, I've done it all for you. Okay, so the mean is 47.3. The median, I've lined them up in order and found out the middle one, that's 47. The mode is 39. Again, in this case, 39, because there's 2 of them. That's not the most useful speed, because that's also the lowest speed. Well, 33 and 29 are lower, but most people are well over that. See, 61, 60, 50, it's well over 39. So, 47 or 47.3 would be a good average. Okay, this is a lot of work adding up all those numbers and divide by 15. There's a lot of numbers writing in order and doing that. Use your calculator to work out mean and median. I'm not going to show you that in this video, but I will show you later on. Okay, and depending on what type of calculator you have as well. But definitely learn how to use your calculator to do the mean and median, because this is just a lot of work and easy to make mistakes in both of these processes. It's fine if you've got 5 numbers or even 8 numbers, but if you've got 15 or more, use your calculator. This is just a little note, a side note for those of you doing IB maths. There's 2 types of mean, sample mean and population mean, and basically they're worked out exactly the same way. You use all the same formulas. Just sample mean has the symbol x bar, and population mean has the symbol mu. So if you add up every single value in the whole population and divide by the whole number of population, that's the population mean. But if you just take a sample of that, so not the whole population but just a portion of the population, you should use the symbol x bar. Basically, for most of you, just use an x bar all the time is going to work. They're the same formulas. You just got to be aware that there's 2 different possible symbols. Talking of formulas, here is the formula. Now you look at that and you get a bit freaked out, a bit scared. But actually, it's not that difficult to understand. I'm going to show you with an example. Here we've got the formula, here we've got our data. So there was some situation in which people could score 6, 7, 8, 9 or 10. And 2 people scored 6, 6 people scored 7, 9 people scored 8, 6 scored 9, and 2 scored 10. So in terms of these letters here, that's X, the score is X, and F stands for frequency. Pretty lucky that. It's nice to speak English. F for frequency. But what's these little i's here? Well, I equals 1 to k, maybe 1 to n would be better there, because, no, 1 to k, because we have 1, 2, 3, 4, 5 different scores, so this will be from 1 to 5, and that's x1, that's f1, that's x2, that's f2, etc., etc. So all you do is you do 6 times 2, or 2 times 6 probably, f times x, and then you add them all together. So 6 times 2 is x1 f1, 7 times 6 is x2 f2, and plus you're adding them all together. This down the bottom is the sum of all the f's, which is your n. Okay, so really this overly complicated formula, don't let it scare you. Just remember you've got to do every single x value, so that's each x value times its frequency, and you sum them all together. And the n is the total number of frequencies. So all that work there will give you a final answer of 8, which makes sense when you look at this, right? The average score's got to be somewhere between 6 and 10, because that's our limits. And 9 out of the 25 actually equal 8, and it's evenly distributed. Look at that, 2, 6, 9, 6, 9, 2. So 8 makes a lot of sense. Okay, one final question, and this comes from the Oxford Maths Standard Level book, the old edition. There's 4 apples, and the mean of the mass of the apples is 124 grams. If I add in another apple, the mean mass is going to change to 132. How much did that apple weigh? So you know the answer is going to be something around this. It's probably going to be pretty big, because it's increased the average mass by 8 grams. So what do? Well, 4 apples has a mean mass of 124, so the mean is the total mass divided by 4. So the total mass is 124 times 4. So the total mass of your 4 apples is 496. The mean of 5 apples is 132. So the total mass of 5 apples is 660. 5 times 132. So the mass of that remaining, or that extra apple, must be the one apple that turned 4 into 5. So you do this mass of 5 apples minus mass of 4 apples, which is 164, which is quite a heavy apple. Okay, I hope this little theory and this couple of examples help you understand mean, but also median and mode a lot better. Alright, see you another time.